we have a Dr. Pedro Peinado. He is going to give a talk on mathematical and correlation between the Shroud of Turin and the Sudarium of Oviedo. Trying to switch back, sorry. Dr. Pedro Peinado is a researcher and educator with specializing in sinology and mathematical modeling. He holds a PhD in educational technology and degrees in business administration and e-learning. Mathematics and research methodology teacher. He won the Jenner de los Rios National Award for Educational Quality in 2017 for his project Planting Numbers. He is a member of EDICES, responsible for the data analysis and studying on the Sudarium of Oviedo. Currently a PhD student at the University of Oviedo. His research focuses on the mathematical structure of the Oviedo shroud, the cloth. And I want to give you guys a warm welcome to Dr. Pedro Peinado.
Thank you. Thank you.
Get out of here.
I'm not here as an individual researcher, but as a part of a team. What you just saw is the workshop of Juan Manuel Miñarro, Doctor in Fine Arts and Professor of Anthropology. Together with him and with the constant help of Dr. Antonio Petit from the medical field, I've been able to develop this work. We are a team that works together every day, even though we live 500 kilometers apart. Whether through a WhatsApp, phone calls or video meeting, we stay in touch every single day. And when life allows it, we travel to work side by side. This presentation is as much there as it is in mine. We is this together all the way. Good morning. Before I dive into the heart of my talk, I want to thank the organizer. It is truly an honor to be part of this forum and to share this space with a global researchers and speaker. To be here today is only a privilege, but also a responsibility. To bring something valuable to the table and to learn from each other. Honestly, I wish I could explain all this in my native language, Spanish. This is very complex topic, and English is not my very good, I'm sorry. But I work hard to be at to this event. So thank you for understanding. I will do my best. I give it my all. Before I begin, I would like to point everyone here to a previous study I made called Probabilistic Analysis of Route, Sudarium, Jesus de Nazareth. In that research, I proposed some probability model based on 15 shared features between the shroud, the Sudarium, and the historical figure of Jesus of Nazareth. The result showed a probability higher than 90%. In fact, with 12 nines after the decimal point. That's all. That's all. These features belong to the same person. So, based on that result, in this presentation, I will work under the idea that the man in the shroud and the Sudarium is the historical Jesus of Nazareth, because he's the #1 candidate, and right now, there is no #2. This is my starting point, and I'll stick to it. I am continuing the line Cesar Bart started this morning, and it's very important. Jorge Manuel Rodriguez Almenar talks this afternoon. It's really important and necessary. I give great context to his field. My presentation has two parts. First, I will talk about the mathematical match between duplicated areas in the Shroud of Turin and the Sudarium of Oviedo. Then, in the second part, we will go further. We will look at a special structure that we call the inverted V-shaped stain. and suggests this disappears on both clots. Let's go step by step. Explaining my work is really a challenge in Spanish, so dining in English means I'll need a bit of help and understanding from all of you. I'm sure I can count on that. Let's begin with the central object of this study. I'm sorry, the central object of study is in my packet. I confirm it's a copy. Later, tag new with him. Let's begin with the central object of this study, the Sudarium of Oviedo. This is a small or wrinkled cloth, traditionally known as the Sudarium Domini, the cloth of the door. What we see now is the reverse side, the back of the cloth, where we find a dense and complex pattern of stain. Although it might look simple at first glance, there is more than meets the eye. And this is the front side, or obverse. The name obverse and reverse were chosen when the team led by Guillermo Heras first arrived in Oviedo, together with our president, Jorge Manuel Rodriguez, who is here with us today. At the moment, the visible side, what as we now call the obverse. It is important to compare both cloths, especially their dimension. The Shroud of Turin is a large linen, more than 4 meters long. The Sudarium of Oviedo is much smaller, about 85 for 52 centimeters. But this difference doesn't stop us from finding a strong connection between the marks on the both cloths, as long as we use a shared geometric approach. Let's begin with the mathematical correlation. It's very important to say that this research is only possible because the foundational work done by EDICES, the research team of the Spanish Center of Syndonology, over the last 38 years. More specifically, this part builds on the anthropometric research led Dr. Miñarro. The correlation process was done in 5 main steps. First, we started with the anatomical zone defined by Dr. Miñarro. These areas are likely to contain a blood stain caused by the same origin. In other words, the stains were selected based on position, not on their shape. Second, we got to be more precise by using 17 reference points. In the end, 16 points were fixed and made smaller to improve accuracy. The smaller the point, the more accuracy the measurement. Third, they applied the methodology, which is maybe the most important step to make sure the results are valid and can be repeated. Fourth, we did the mathematical calculation using different correlation models to study the alignment between both clocks. And finally, some months later, we add a new zone to the analysis, a segment from the particularly important area. In the image on the left, we see the highlighted area that reflects higher intensity on the Sudarium. When transferred to the shroud, these areas can be seen on the right together with the anatomical comparison studies. There are the zones we'll focus on as they offer the clearest class. In this slide, we'll show four key images, all scale anatomical aligned by Dr. Miñarro. The first and second image show the forehead area. We have drawn 2 axes, a vertical axis which follows the center of the body, and the horizontal axis based on matching anatomical reference in both cloths. We can find we can find the same reference also in the occipital area, the back of the head. This axis helps compare the stain in a consistent and reliable way. Once the images are aligned, we can see two superimposing views. These show the stain from the Sudarium placed over the Shroud of Turin, the positive image on the left and the negative on the right. As you can see, the anatomical match is very clear. Once both were aligned anatomically, Dr. Peinado started to identify blonde stains that could appear on both cloths. Not because they look exactly the same, but because they share the same anatomical position. In this case, we are looking at forehead area. It's about location, not appearance. Still in the same area, Dr. Peinado reduced the stain shown to dot as a first step toward more precise making. This dot became the first reference point in the correlation study, but at this stage, they are still too big for accuracy measurement. So, in the next phase, it was necessary to adjust and refine them. The same process was done in the occipital area, where we also found matching pattern in both cloths. This pattern we are not selective for their appearance, but because for their position and their underlying geometry. Now, it's time to reduce those dots into smaller ones, so we can start measuring with better precision. Now, we can see the forehead area with the reference point already reduced in size on both cloths. What's good for front, what's good for the front is good for the back. The same precision criteria we apply to the occipital area. The same precision criteria what they apply to the occipital area, just like we did before. The process of mathematical correlation between the stain followed a step-by-step sequence in how we apply the method. First, we did a pretest with a reduced scale for the cloths using measurement at 50% size. This helps us adjust the method without affecting the actual dimension. Second, we did a methodological review, correcting and improving our measurement criteria. Third, rescale the point precisely, looking the more accuracy and consistency in the model. And finally, we ran the fall test at the 100% scale, and that's what gave us the result you are going to see next. Fingerprint identification is a technique with more than the 120 years of history. It is based on comparing unique pattern in each person. This method doesn't need an exact match. What matters is a structural congruence, a consistent relationship in shape, proportion, and position. Let's face it, it doesn't enough to identify a person from not just one finger on only one side. Why not use a similar method to compare two sets of blood stains on different cloths and on two opposite sides? To sum up, we have selected 8 points on the forehead and 8 more on the occipital area. We believe these points may come from the same blood source. We measure the relative distances, linear and angular, between the point on the shroud, both in the forehead and in the occipital area. Then we did the same with the Sudarium. We compare those distances and their deviation. And finally, we applied mathematical methods to check whether they are correlated or not. Using a well-established method is key to getting reliable results. In our case, we rely on lophoscopy, the comparative study of unique characteristic markers. This technique helps see the stain as comparable shapes, and it has been used for over 100 years in forensic science to identify people. We adapted to compare blonde stain on both globes, following the method described for Anton and Barbera. For the comparison to be valid, we need three basic conditions. First, there must be clear or unique marks. Second, they must have a similar shape. And third, we need a minimum number of matches. In the next step, we'll apply this method to the forehead and the occipital area in both the shroud and the Sudarium. Although the method says that the number of matches is not the only thing that matters, it's still an important factor. When the mark of stain are unusual or distinct, we don't need so many matches. But when the marks are more common or generic, we need a higher number of coincidences to make a strong case. In our case, we have 16 coincidences, enough to meet the standard of every court in the world except France. But as we'll see in a few minutes, even France won't be able to say no. I am so glad by my neighbors. We use the same principle to study the possible match between the stain on the shroud and the Sudarium. Now, unlike classic lithoscopy, we are not comparing shape. It's very important. We are not comparing shape because blood stains are not stable as fingerprint features. This is my focus on their relative position instead on their form. Here, the forehead area on the shroud is shown. The image presents the measurement between points 1 and 6. Each pair of points were measured in three different ways: center to center, center to edge to edge of the circle. From these three values, an average calculated to obtain a higher precision in the result. In this specific image, the center-to-center measurement is displayed. The green line indicates the linear distance, while the black line representing the angle. At the top right, the measurement data can be seen with the two key parameters, distances and angles. In short, a double measurement was performed, linear and angular. Now, the center-to-edge measurement is presented. The green line indicates the linear distance, while the black line represents the angular value. As before, both the dimensions were stained from the same pair of reference points. And finally, the edge-to-edge measurement on the circle is shown. The green line marks the linear distance, and the white line represents the angular measurement. This completes the three measurement types applied to each selected pair of points. I'm sorry, this is one of 4 point-to-point correlation tables between the shroud and the Sudarium. There are 4 different tables, one of each dimension, that is angular and linear for each of the 2 anatomical areas, for forehead and the occipital area. In this case, the table shows the angular measurement in the occipital area. Each row corresponds to the measurement each of pair of points, with its angular value and the calculated percentage of deviation. All values shown here we obtain using the methodology described earlier. It can be seen that after taking 3 measurements, an average value was calculated and then used at the final measurement. This helps to ensure consistency and give the result within the reliable margin. Then, the deviation of each measurement were calculated for every pair of points of each cloth in 2 dimensions, angular and linear. This provides a more complete picture of the variation. Here, the scatter plot is shown, displaying both the point cloud and the regression line for the longitudinal measurement in the forehead area. Each touch represents the measured distance between 2 points. The regression line shows the ideal trend that would occur if all values were perfectly aligned. As observed, most points lie very close to the line, which indicates a strong correlation. This is confirmed by R-squared value 0.956, a remarkably high result. It's worth remembering that the maximum possible value is 1, and any value about 0.8 is already considered very strong. This clearly stands out from the noise. Once the 366 measurement had been obtained and verified, the correlation analysis was started. First, an ANOVA test was applied to determine whether a correlation existed. The result was positive with a very high statistical significance. In fact, the smallest difference among the 4 cases, that is, forehead and occipital area on both the shores of the Sudarium, was 10 million times above the minimum threshold. In short, the signal was far too strong to ignore. Then, the strength of the correlation was evaluated using 3 statistical tests: Pearson, Kendall, and Spearman. This slide presents a summary of the average value obtained for the 3 tests across each anatomical area. The final result is a global average of 83.75%, confirming that the correlation between the 2 clots doesn't depend on a single mathematical model. All 3 tests consistently indicate a high or very high correlation in both clots and angular measurement. In other words, based on mathematical evidence, it is possible to affirm that the Shroud and the Sudarium covered the same head. What truly matters is not only the high correlation value. What matters is how correlation helps to understand the margin of error. The analysis indicates an estimated error ranging from 13 to 16%, which I define it as systemic error. This is not a flaw in the method. It's a natural part of the phenomenon, mainly related to the natural structure of the clots. Several factors contribute to this: difference in tension, presence of wrinkle, different information times, uneven exposure, or even hair interference. Additional influences include the body angle, fabric deformation, and the preservation condition of each clot. Nevertheless, this margin of error is expected in a comparative study of this nature. What is shown is that the correlation is a robust, subject to natural variation, though, in fact, if the match had been perfect, that would have raised a red flag. This is the Sudarium at sea at first glance. Now, it is shown under grazing light. It is striking how many wrinkles become visible, and now many intrinsic distortions are involved when attempting to measure this clot, as if it were flat. In reality, the surface is anything but uniform. Here can be observed that both clots put pressure on the body in a different way. In the Shroud, the fabric appears to fall naturally over the body, whereas in the Sudarium, it got pressed tightly against the face. Over the past month, and this will be explained in more detail on Saturday, folding pattern appear to have been identified, indicating how the cloth was pressed and shaped, leaving visible marks on its surface. Could anyone in this room determine with precision where the exact wound lies beneath each stream of blood? This is why perfect measurement is impossible. But when the correlation is this high and the differences can be explained, The result displays a level of absolute coherence. And finally, I think that something error might confirm the theory, and this is the case. This is an example of what we can call the most natural error. For several die, 0.3 and 8 gave good angular values, but the linear distance was too far off. I didn't know what's happening. I was desperate until I asked Juan Manuel Miñarro, and he said, I believe there was an inflammation in that thumb. And that was it. Until I asked, I believe, the deviation wasn't measured mistake, but the result of a real natural effect. This kind of deviation doesn't not weaken the model. It's made it more realistic because it reflects true anatomical condition. They express variation in a complex physical and textile system. So then, if these stains are analyzed in the same way as fingerprint, and they come from two different clots, and if the stain can be positioned within a coherent anatomical space, then what is present is not a coincidence, but a structural match can be scientifically evaluated. In other words, this move from pattern to proof. If, in addition, one these clots, the shroud, provide the necessary data to reconstruct a specific anatomical model, then the selected stain can be positioned within that model. And one step further, what's taking the application of area-based correlation. This method moves beyond point-to-point comparison, analyzes entire contact zone, evaluating their shape, orientation, and geometric distribution. This opens the door a higher level of structural insight. Up to this point, the analysis has focused on point distances and angles. From here onward, the focus is to complete shape, which can be compared based on geometry and proportion. The process begins with a particularly significant feature, the inverted V-shape stain. This shape doesn't adjust just where point is contributed an entire surface. Therefore, it can now be started. They are not 16 match, they are 17. Even France will have to assess this level of correlation. And on Saturday, they will be much more. Feature solve. The internal layout of the Sudarium must be understood. On the right, the river side is visible. The left side of the river side was in direct contact with the face, while the right side received blood after passing through 3 layers of clots. In other words, the blood followed this sequence. From the river side, is the river side. River side right. Transfer ambers left. For contact, pass amber right. Sorry, amber left. finally, to reverse right. All right? First, sure. The blood pass the body at the river side. The river side. The right river side.
So the way it was folded is critical.
The blood is passing. The four. Thank you.
Notice that it doesn't come all the way across. They had to attach it in the back.
Okay.
That way.
Thank you. Thank you very much. The horizontal and vertical guides can be placed to mark the approximate position to the central facial stain on each cloth. In the Sudarium, this stain appears duplicated as a direct consequence of the layering process just described. Here we include a facial reconstruction created by Dr. Minervo. The image was generated using artificial intelligence based on his anatomical sculpture. In the face behind the cloth, brought back to life through science. By comparing the three images, it's become clear that the stain on both close align with the characteristic features on the face. This supports the conclusion that the stain are not rounded, but follow a coherent facial structure instead. At this point, we need to pause and take a closer look at the Sudarium of Oviedo, especially regarding the formation of the stain. We know that the Sudarium at least two positions over the head. The first position was with the cloth folded as seen in the image on the left, and the places over the face as shown in the image on the right. To understand the pattern, we must first understand the posture. As a result, the central stain due to the folding on the cloth passed through filtration and contact to 3 additional layers. This produces a total of 4 main imprints. On the left, we have a reverse side. On the right, the adverse side. Now, we can see the symmetry axis to the central image, which corresponds to the folding line of the Sudarium. We also distinguish left and right of the reverse and left and right of the obverse. Let's now separate the 4 surfaces, because each one of them has a different story to tell. Now, let's place the layers in the exact order in which the blood was transferred. First, it passed from the body to the left reverse by the direct contact. In this time, it's okay. Second, by filtration, it's passed from the left reverse to the right obverse. Then, as cloth was folded, the blood moved by contact from the right obverse to the left obverse. And finally, it's passed from the left obverse to the right reverse, again by filtration. The Sudarium, this facsimile, including the white area, this is the Sudarium with the dimension we believe each originally had 2 by 1 US cubit. From the left, it's a journey told in layers. Therefore, it's clear that the primary stain were gradually reduced due to the loss of material from one layer to the next. Now, placing ourselves back in context, we return to our core question. Why doesn't the inverted V-shaped stain appear where it should? It's appear here instead. Let's explain this. On the shroud, the image on top, the inverted V-shaped stain is clearly visible. However, the Sudarium, the stain is not detected where expected. That is, on the left reverse, which is the main contact zone. There is so much overplaying fluid in that area that it becomes difficult to identify a specific structure. But when examining other zones, the stain appears on the right reverse. And these shapes show a very rational symmetry compared to where it should have been. In other words, the stain has not disappeared. It's a simply sieve through filtration, while still preserving in overall structure. We now identify the geometric structure found in the facial contact zone, both in the shroud and the Sudarium, on the river side of the Sudarium. In both clots, the same relevant stain had been marked in relation to their relative position. The inverted V-shaped structure is highlighted with the orange circle. Its shape is clear and defined on the shroud, but it appears less distinct of the Sudarium. And the left and right reverse side of the Sudarium are symmetrical. The structure tends to repeat, but with inverted symmetry. To compare them properly with the shroud, the image needs to be rotated around the vertical axis. This is when the structural symmetry becomes clear, especially in the inverted V stain, which, interestingly, is the one that matches the patch. On the left reverse, this stain is not visible due to the presence of various fluids in contact with the body. However, thanks to filtration, this stain appears clearly on the right reverse. I must insist that these structures are hard to see on a standard screen, but thanks to Barry and Bernard Miller image and the Sudarium scanner, the shape that define and complete the structure become clearly visible. Like the hexagonal stain, highlighted with the circle on the right, on the circular feature that seems to divert the blood trail, marked with the larger circle on the left. We now mark the symmetrical zone between the left and the right reverse side of the Sudarium. Using colored outline, we can observe how the main formation repeats, but with a mirror symmetry, as reflected across a vertical axis. As we can see, this structure is fully comparable to what appears on the shroud. This is not a coincidence, but the result of a double process of contact and filtration we've already discussed. The comparison shows that the stain preserves their relative structure of R&D position shift due to the folding and mirror logic of the cloth. Now, how? When comparing the shroud with the right reverse side of the Sudarium, we can clearly see the repetition of a structure of equivalent zone. The elliptic shape marked on both sides show a parallel alignment. The smaller blue circle reinforces the presence of a well-defined shared structure. Once again, this comparison shows that the stains are not rounded, but follow a coherent geometric organization across both cloths. And here we can observe that the internal angles of the formation are almost identical on both cloths. This very small difference supports the idea that there is a shared structure reproduced at high geometric consistency across two distinct physical objects. Now, we'll look at the transformation of the structure from the shroud of the Sudarium, and you'll see how the shape fall into the place. I'll repeat the animation a couple of times because I know the screen's resolution might not show every detail clearly. Okay? So like. But the important thing here is to observe how the shapes align and how the alignment reinforces the geometric match. The correlation is completed between the Sudarium and the Shroud by using its two complementary sides, the left reverse and the right obverse. We have marked the two most significant boundaries, the epsilon shape in green and the inverted V in blue. Finally, we observe the forehead stain for the Sudarium alongside the homologous structure on the Shroud. The geometric match between both cloths is so precise that I believe we have clearly replicated in the structural correlation. I finished. This image, created by Dr. Peinado, is not a symbolical reconstruction, but the result of the rigorous investigation. Based on the stain for the Sudarium, the anatomical proportion on the Shroud, later the application of the criminalistic method led us to mathematical correlation test, with result that in any other context would be more than enough to confirm an identification. And is there one point that must be absolutely clear in this presentation is this: the data for mathematical lead us to a clear conclusion. The Sudarium and the Shroud cover the same human head. In the age of science, in the age of number, in the age of mathematics, to an objective age, mathematics show the undeniable. And moreover, they highlight the value of the description in John 27. Let's now last sight of this point. It's key for us. This is not just a title. This is a heart of the matter. Thank you very much. I promise I'll show something really powerful on Saturday too. Thank you very much.
I'd like to ask Fernando to translate so it comes best.
Thank you very much.
Tell him, please, he is being broadcast on social media worldwide. Go ahead. And I have a follow-up.
Les están viendo en social media en todo el mundo.
Fantástico. Un saludo.
People can touch the screen to say they like.
Pueden tocar la screen para decir que le gusta.
Vale, que
Tell him he has over 23,000.
Tiene más de 23,000 puntos.
Muchas gracias. Fernando, por favor. Bueno, para los hispanohablantes, muchas gracias. Y eso que mi inglés es horrible. Entonces, que me perdonen.
Spanish speaking that are watching, he wants to thank them, but for the English speakers,
It's so-
he's really grateful.
It's so difficult speaks in English this field for image in the English and not speak good English is for me very difficult.
You mentioned that you think it's a 2x1 cubit. Are those the same cubit sizes that would equate to the shroud?
Creo que entendí que 2 por 1 cubo, igual que la sí, efectivamente es por eso. I think the Sudarium is le falta un trozo porque el proceso de envoltura de la cabeza no es coherente con estas dimensiones.
Yeah, so the Sudarium, since it has the wrinkles and the whole process of covering isn't going to be exact, but he says it's close enough for forensic studies.
Y en los últimos 2 meses, en los
Last 2 months,
últimos 2 meses hemos descubierto algo que el sábado voy a contar y por lo que refuerza esta idea.
So he's saying that in the last 2 months, they've actually uncovered more data. He's going to talk about it in Saturday's presentation. So make sure you see his Saturday presentation.
The first ones in the world. And for
Everybody in the world can see it.
Pero yo creo, I think that it's most coherent because los instrumentos de medida entonces eran los codos. Igual que las síndromes eran 4x2, esto es 2x1.
So actually, the system of measurement is actually more coherent in the way that they're doing it now. So, yeah.
So I apologize, I have some hearing loss. What was the total number of points of congruency that you found so far?
¿Cuál fue el número total de congruencias, de similaridad entre las dos telas? ¿Cuántos puntos de similaridad entre las dos telas?
Es que no le puedo responder a eso así. Es decir, es que lo que se hace es dos nubes de puntos.
Yeah, he says it's not exactly that. Two levels of points of congruence.
A cloud of point, for certain area, and for... No, puntos de congruencia no. En principio fueron 8 y 8. Pero el sábado voy a presentar 54.
So he studied the 8 from the forehead and the back and made sure that they all are lined up.
Right.
On Saturday, he's going to talk about 54 additional points of congruence that they've been able to uncover.
Sí, porque voy a mostrar la extrapolación al espacio de la corona de espinas.
Now, keep it, yeah.
De la corona de espinas.
So he's going to include the crown of thorns and the congruence with those elements, with those points. And keep in mind what he said at the end, that just with those points of congruence, they would be able to show that the two laid over the same person at the same time with complete assurance based on forensic science.
So basically, invisible to any court in the world as
Sí, admisible que todo esto es visible en una corte de leyes como para poder...
Claro, es que los puntos de coincidencia, por ejemplo, son 12 habitually.
Yeah, so yeah, he says actually, yes, what you just said, so in a court of law, enough to convict anybody.
Wow, wonderful. Thank you.
Some results from several countries that you showed. Were the mathematical correlation algorithms the same as what you used, or did they do independent, different techniques?
En los diferentes países que enseñaste, si los puntos de correlencia están bien.
Sí, pero es que aquí hay una cuestión que es muy importante. Yo ojalá pudiera explicarla en español. Lo importante es que hay dos partes. Una cualitativa, si quieres me vas traduciendo.
Okay, so what he's saying is that there's several other areas that need to be considered. One is the qualitative side,
Y otra cuantitativa.
and then the quantitative side.
Si los puntos son muy comunes,
If the points, if they were really so common, lined up,
entre 8 y 12 son suficientes.
between 8 and 12 points would be more than sufficient.
Excepto en Francia, que son 17.
In France, they said they had 17 points of similarities.
Pero si no son comunes, si son extraordinarios, como es el caso, por ejemplo, de la U invertida,
So in the case that he's showing, because of the inverted cloth and the points that inverted, then entonces,
haría falta muchos menos.
they said it would be even less. You don't need so many points of
Porque
congruence.
hay marcas tan definitivas que solo están en un cuerpo.
Yeah, there's some marks are so defined that they only just one in one area would be enough.
Thank you.
We have time for one more question.
The blood type match.
The blood type.
It's AB positive.
Si la sangre AB es positiva, si son las dos, si pudieras hablar de eso.
No porque no soy forense, yo soy matemático.
He says he's not a forensic scientist, he's a mathematician.
Pero es AB positiva en los dos.
But he says it is AB positive, yes.
Pero es muy importante que por eso en este estudio y en el del sábado solo estudiamos manchas de sangre para no incluir la impronta de la síndrome. y no mezclar tipos de manchas.
So, yeah, so what he's saying is that the study that he's doing just matches, mathematically matches the actual stain, but not the blood type. But yes, he did confirm that it
He
is AB
didn't
positive.
check blood type, but has any other scientist run a blood type on the Sudarium?
Que si han corrido, otros científicos se han corrido que es AB positive.
Sí, sí, claro,
Yes.
nuestro equipo.
Yes, they have.
Sí, sí, sí. Y dos veces.
Se hicieron tres identificaciones distintas y dieron AB.
Today at 3 p.m., Jorge Manuel here, he's actually going to make a presentation about that. He will include it in his presentation. But there have been three different studies that have shown, AB positive.
AB positive. What's on the shroud?
All right, thank you. Thank you, Dr. All right, we're going to take a short break. We'll be back at 11 o'clock. 11 o'clock with Dr. John Jackson.